Welcome to all the learners, and in this lesson we'll be doing the paper of 2023, specifically paper 1, question 1 to 2. Let's get started. So the first question, as per usual, would be typical solving for x questions. So let's have a quick look. So the first question, solve for x, when we have x squared plus x minus 12 equal to 0. So immediately I can see this will test our factorization, as I'm expecting two answers for x. So let's get started. So for 1.1.1, we will say x squared plus x minus 12 equal to 0. We need to factorize. It will be x plus 4 multiplied with x minus 3 equal to 0. This means that x plus 4 will be equal to 0, or x minus 3 will be equal to 0. So x will be equal to negative 4, or x would be equal to 3. Once again, remember, if you struggle with any of these concepts, please go back to all the other previous lessons and focus specifically on the section you need help with. So let's continue on. 1.1.2. Also solve for x, and we are expecting two answers. However, answers correct to 2 decimal places. So immediately I know I will not be able to factorize it with the rules. We will have to use the quadratic formula, hence the decimal places. So let's get started. First of all, I need to rewrite it first to get the correct format. So it's 3x squared minus 2x equal to 6, meaning it's 3x squared minus 2x minus 6 equal to 0. This means that a would be equal to 3, b would be equal to negative 2, and c would be equal to negative 6. So it's ideal to make sure your signs are correct and first write down your a, your b, and c as it's written in your equation. Always make sure the correct order, meaning the ax squared plus bx plus c. So it must be in descending order of x. Right, now we can go and say x is equal to negative b plus or minus b squared minus 4ac over 2a. Now, negative, please show your substitution, plus or minus. Be careful for your signs. Make sure you substitute correctly every time. Everything over 2a is equal to 3. Now remember, the plus and minus indicate the two different answers. So you literally just type it into your calculator and you would get x is equal to 1,79 or x is equal to negative 1,12. And just take note, if the question says 2 decimal places and you get an answer of x equal to 1,3, remember to put a 0. If the question states 2 decimal places, the answer must be in 2 decimal places. So just remember that, the 1,3 0, but in this case it worked out perfectly as everything had to be rounded off. Okay, next question, let's have a look. The square root of 2x plus 1 is equal to x minus 1. Right, let's quickly have a go at that. Let's go to the next page. So now we have 2x plus 1 equal to x minus 1. So remember, with the surd questions, you prefer to have everything with the surd on one side and all the rest on the other. The reason being, we would like to square both sides. So now I have 2x plus 1 equal to x squared minus 2x plus 1. Please remember that you have to rewrite this bracket twice, as the whole bracket is being squared, so there is a middle term. Right, again, two answers for x, we need to factorize. So I will get a 0 equals x squared minus 2x minus plus 1 minus 2x minus 1. Let's quickly have a go. So we're left with x squared minus 4x. Again, factorize. First the common factor, x minus 4. So x would be equal to 0 or x would be equal to 4. Now remember, specifically with the third questions, we have to verify that both answers will be acceptable. Meaning, I need to specifically look at this third for starters, this 2x plus 1. If I substitute the 0 in, it's 2 times 0 plus 1, which is just 1, which is perfect. And with the 4, I'll get 2 times 4 plus 1, which would give me 9. And the reason I am looking for this is, please remember that with these questions, you can't have a negative value underneath the third. For example, if this was 1 minus 2x, the x to 4 would not be accepted because it will give a negative value in the third. So please remember that. Always check. But in this case, both answers will be accepted and we leave it as is. If we had a value that we could not use, we would just simply say not applicable. Right, next question, the 1.1.4. Let's quickly have a look. That's your inequality, x squared minus 3 larger than 2x. Let's have a look. So x squared minus 3 larger than 2, let me just correct that. So it's x squared minus 2x larger than 3. Again, not the correct format. I need to bring the 3 over. So it's x squared minus 2x minus 3 larger than 0. Factorize x minus 3, x plus 1 larger than 0. Very important, the difference between inequalities and the normal equations would simply be these critical values or critical points, where I say x is equal to 3 or x is equal to negative 1. So now I draw a little parabola to help me with the answer, negative 1 and 3. And now I look, this must be larger than 0. So it will be above the line. So it would be two different answers. So either x should be smaller than negative 1 or x should be larger than 3. Two different answers. Please draw the parabola. It makes it so much easier to actually get the correct answer. Now, let's continue with question 1. And the next two questions is referring more to a simultaneous type of question. So first of all, we have solve for x and y with this equation and this equation. So it's simultaneous for 5 marks. The thing is, you only have 5 minutes in exam to complete this, and we're trying to make up a bit of time. So let's get started. So if I have x plus 2 is equal to 2y, I'm immediately going to make x the subject, so it's 2y minus 2. That is equation 1. Then I have 1 over x plus 1 over y is equal to 1. Now, very important now, if we look at this equation, I don't like that x and y is in the denominators. So I simply multiply everything with x and y. It's an equation. We can do that. So if I multiply everything with the x, y, those two cancel out. I'm left with y. Plus, multiplied with x, y over 1, those two cancel out. I'm left with x. Equal, multiply with x, y, and I just have x, y. And this is my equation 2. Now I state 1 in 2, meaning I'm rewriting it. It's y plus, instead of x, I write 2y minus 2 equal to, instead of the x, I need to stipulate 2y minus 2 times y. Quickly multiply in, we need to simplify. So I'll have 3y minus 2 equals 2y squared minus 2y. Let's continue on. I know I'll have to factorize. So it's 2y squared minus 2y minus 3y plus 2. So let's quickly have a look. So we have 2y squared minus 5y plus 2. We need to factorize. Once again, you could use the quadratic equation. Alternatively, I'm immediately going to check for common factor. Don't see it. Dots, definitely not. It is a trinomial. Get the two brackets. Once again, if you're stuck and you're uncertain on how to do the questions, please go back to the factorization where we do it in detail. So we typically have 2y here and y here. So we have 2y minus 1 equal to 0, or y minus 2 equal to 0. So y is equal to a half, or y is equal to 2. Now, the question didn't say solve y, it said solve x and y. We need to substitute back, and ideally use equation 1. You already rewrote it exactly the way it should be to get x. So I will say x is equal to 2 times a half minus 2. And that would give you a negative 1. Y is equal to 2 times 2 minus 2. That would give you a 2. So the two coordinates is negative 1 and a half, and 2 and 2, like that. So please remember, ideally, give your final answer in coordinate format so they clearly can see the exact final answer. So let's go back. Let's have a look at the next question for the question 1. Given, and they give us this equation where m and n are integers, determine the values of m plus n. Now, very important, I'm immediately seeing similar bases on both sides, but not the same bases when I compare the sides. So what can I do? Let's quickly get started. So we have 2 m plus 1 plus 2 to the power of m is equal to 3. Let's just check it again there. 3n plus 2 minus 3 to the n. Now, if you're ever stuck, the first thing to do here would just be to break it up. So I'm just using the exponential laws. And I know I can factorize by taking out a common factor. Let's have a look. What do we have? So I have 2 to the m times 3 equal to 3 to the n times 8. So again, one more step first, because I need to get it in prime base. Now, very important. When we do exponential equations, we can only compare the same base. What do I mean? We can only say that 2 to the m should be equal to 2 to the power of 3, and that 3 to the power of 1 is equal to 3 to the power of n. That is really important. So now I can actually solve for m and n. So m is equal to 3 because it's the same base, and n is just equal to 1. So therefore, m plus n would simply give us a 4. And that's the final answer. So remember, only the same base can be compared. Right, let's quickly continue to question 2. So let's read. Given the arithmetic series, so already I know there's a constant difference. If they did not say arithmetic, I had to check whether it's geometric, arithmetic, or quadratic. So I know there's a constant first difference, plus 5, and a plus 5. So let's quickly have a look. So the first question they ask us is to determine the value of T91. So obviously I first need to get the Tn, the general term, before I do anything else. So 2.1.1, Tn is equal to A plus n minus 1d. So my A is 7 plus n minus my common difference or constant difference would be 5. Multiply the 5 in and you'll get 5n plus 2. That's the general term. So that implies that now we just need a calculator real quick. To calculate these values, we would have to say that T of 91 is actually equal to 5 times 91 plus 2. Quickly type it in, and we get 457. Done. So remember, A is 7 and D is 5, because now they're asking for the sum of the first 91 terms. So once again, we have two options here because we do have the last term. So I'm going to prefer to work first, or to work with the equation that states that Sn is equal to n over 2 A plus L, meaning A the first term, L the last term. So S of 91 is 91 over 2, and it's 7 plus 457. And let's quickly calculate that. So remember, you could have used the other equation as well. It would have been 100% correct as well. And we get a value of 21,112. And that's the answer. And that's for 2.1.2. Again, let's quickly go back. The last question states, calculate the value for n for which Tn is equal to 517. Right. So they're giving it already for us that they're looking for n, and Tn is equal to 517. But what do we know about Tn? We already got it in the first part of this question. So we will say it's 5n plus 2 equal to 517. Let's solve for n. So we'll have 5n is equal to 515. Divide both sides by 5 and you'll get n is 103. Therefore, term 103 is equal to 517. And that is your final answer. Let's quickly do the last part of question 2. So they're giving us the following information about a quadratic number pattern, meaning a constant second difference. What do we have? We have the first term would be 3. So let's quickly try and break it down. So 2.2.1. So your first term is 3. Term 2 minus term 1 would give you a difference of 9. So I know for first difference it would be 9. So I say 3 plus 9 and I have my second term. The difference between term 3 and term 2 would be 21. Again, add 21 and we'll get 33. Right. Now, very important, they are specifically saying it is quadratic. So I know there will be a constant second difference. So if it were to continue on, it would be a constant difference of 12, meaning of 33, because it's 21 plus the 12, 33, meaning 33 plus 33 would give you 66. Now again, add 12, because I can see we need to get to the fifth term. So if we add 12 to this 33 here, and we continue on with this pattern, we'll get 45. Again, 66 plus 45 would give you 111. Therefore, term 5 is actually 111. Done and dusted. The next one actually stipulates, show that the general term for the pattern is this. So once again, fortunately we already broke this down, meaning I know that 2a is equal to 12, 3a plus b is equal to 9, and a plus b plus c is equal to 3. And now I need to solve, so let's quickly have a go. So I'll first write down 2a is equal to 12, 3a plus b is equal to, let's quickly have a look, 9, and a plus b plus c is equal to 3. So please write it down, and now we can solve. If 2a is 12, it means a will be equal to 6. Now I substitute in 3 times 6 plus b is equal to 9. So b will be negative 9. Substitute in 6 plus negative 9 plus c is equal to 3. And we would get c is equal to 6. So therefore, Tn, the general term, is always written as an squared plus bn plus c. So in this case, it is 6n squared minus 9n plus 6. Right, let's look at the last question now. Show that the pattern is increasing for all values of n which are natural numbers, meaning starting from 1 and upwards, because remember, number patterns always start at the number 1. So that's always your first term. So if I have this equation that states Tn is equal to 6n squared minus 9n plus 6. Now, if I were ever to ask you, sketch the graph 6x squared minus 9x plus 6. Remember, this is indicating a parabola. This is indicating a happy face parabola. And it's increasing from the turning point. So I need to get the turning point. So that would be my first option. So I can simply say n is equal to negative b over 2a, which is equal to negative 9 over 2 times 6. So you'll get 9 over 12, which is the same as 3 over 4. So the turning point is at 3/4. What does that mean? Look at the sketch. From 3/4 onwards and larger than, that means it will be increasing. So I will say for n larger than 3/4, Tn is increasing, which then would imply if n is a natural number, meaning it starts at 1, it definitely falls within this scope. So I could say if n is a natural number, Tn will be increasing. Take note, alternatively, we could have differentiated it, and I could have gotten, so this is option 2, and gotten 12n minus 9. And just remember that for this to be increasing, the first derivative must be larger than 0. So 12n minus 9 larger than 0, therefore n larger than 3/4. That's option 2. Any one of these two would give you full marks. And that's all for this lesson. I'll definitely see you guys in the next one.